All right, so question number 5 on the Math Counts 2019 target round. Problem number 5, 6, 7, and 8. Give me the stinking pen. Sorry. All right, so this problem is one of those problems where like, you gotta be kidding me. But here's what I did. I took this square and I traced it, and we know that point A is, the vertex A is at the center of circle, square, PQRS. So then I rotated the square so that,
Does that work?
that's fine, so that this line was parallel with this line, and lo and behold, it's 1/4. The answer,
1/4.
right, 1/4, 1/4.
As a
So therefore, the answer is 1/4. Now, if one problem is super short, that's telling you that this problem is going to be a beast. So, what I would really like to do is I'd really like to create an equation. So, what I did was I had a number. So I have 2, 3, 4, 0 is equal to a number. And the number I don't type in correctly.
A.
Because the result of my error is larger than the result of my what I really want. So that means that 10 times the mistake number plus my units digit squared minus 10 times the tens digit I really wanted to use plus my units digit squared has to equal this.
You lost me.
Now, I'm looking at this equation, and I could multiply it out, and then I could do some factoring magic, but here's the problem that I wasn't able to get past. I have an m, I have a u, and I have a t. If I just had 2 variables, I might be able to make something out of it, but I have 3. This, I think, is going to be a dead end. So I went to the most glorious of all methods,
Guess and check.
the guess and check method.
My favorite.
So I know we're dealing with a 2-digit number, so I'm going to square 50, and I get 2,500. Okay, well, I know that the difference of my 2 numbers has to be 2,340. So right away, that's telling me that one of my 2 numbers is probably just a little bit bigger than 50, just a little bit bigger. So let's try, I don't know, 52. So I'm going to try 52 squared. Okay, so now I get a number that is larger than the difference I'm looking for, which is a good thing. So 52 squared is equal to 2704. So let's try, I don't know, I'm just guessing 22 squared. All right. Well, because now I can subtract, so if I get 22 squared, then I get 484, so I can subtract the 2. Oh, that is close, but it's not right. So that is telling me, okay, you know what? So if I go to 32, I'm going to get a number that's way too big. If I go down to 12, if I go down, well, 25, the units digit has to be the same. So I'm close, but I can't get there with 52. I need to change 52. Let's try 53 squared. So 53 squared. Okay, so this is substantially bigger. So I know that 22 is not, so let's try 23. Okay, so that is
5.
all right. And so I like this 50 and 20 combination. I just don't know the units digit. So I subtract the 2. Brilliant. 2809 minus 529. Okay, I'm getting closer, but it's not quite right.
How
And
about we go to 54?
how about we go to 54 squared? So 54 squared, but I really do like my 50 and 20. I just don't know the units digit, and I just sort of randomly lucked out on that. Sometimes it's better to be lucky than good. And so then we gotta do 24 squared, and let's see what we get. Ah, jeez.
Your computer likes you.
It's not the computer liking or disliking me. This is completely user error. I am making a mistake. Ooh, now this looks promising because 6 minus 6 is 0, and I have a 0. So this is starting to look really good.
Why don't you just go
So
to
2,
one that would
9. Well, because I'm explaining how I did it. And there we go. So I know the two numbers are
Yay.
54 and 24, and it's asking for the sum of the two digits. So I add those together and I get 78. That one, I think, is the hardest problem to do.
What did I get as an answer?
All right,
Done.
so let's try the last two. Now, I really, truly love these path problems. I like these path problems because,
Ooh, want to hear what I got?
sure, let's hear what you got. And everyone else is going to hear what you got because I'm recording.
Oh, okay, no, I don't want them to hear what I got.
Okay. I'm suspecting that no one in our class got it right, and that's okay. All right,
My guess was
so
about 80 off.
so this is a fun problem that has
I
an.
didn't really understand the right and down thing. Can
I'll
just
show
do
I'll
it
show you in a
down?
second. But this has an algorithm. This has an algorithm that will work in every path problem. So I would take out your paper and get ready to write notes because this one has a strategy that will work every time. So we are looking for how many ways we can go from A to B, and we are only allowed to move either to the right. You can barely see that. You're allowed to move either to the right, or you can move down, which means
Oh, I thought you had to go right then down. Oops.
well, we can go right and down in any order. You can go down, down, right, 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 right,
No,
right,
I,
right,
did, I
down,
thought
down,
you
down.
had to go right first instead of down.
Oh, no. You can
So,
go down first
I
if you
didn't
want.
know that.
It's okay. And the nice thing is, we can't double back. We can't go left and we can't go up. So we don't have to worry about doubling back because then it would take forever. So how many different ways can we do this? Now, here's the strategy. We are going to start at A and ask from A, how many different paths can I take to get to this junction?
1.
1. And so I'm going to write a 1. That's not too surprising, right? How many different ways can I go from A to this junction?
1.
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 Right, because in all of these cases, you're just going to the right, and you've no other choices. So there you have it. Let's do something similar going down. How many different paths can I
2.
take?
1. I mean 1.
1.
I was thinking
How many
you were gonna
ways
go
can
right.
you go?
1.
How many can you go here?
1. 1. 1.
Okay, now that's the easy part.
2.
So, how many ways can I get to this junction?
2.
2. I can go 1 or 2. And I can't help but notice that 1 plus 1 is 2.
Oh, that's nice.
Oh. So that means that this junction will have the number of paths that is the sum of the two preceding junctions. So how many paths can we take to get here?
Would it be 3?
It would be 3.
And then
I can go here, and I'll show you.
6.
1, 2, 3. So how about this one? Well, I can go
That's
3
6,
and 1. 3
7,
plus 1
6,
is?
6.
3 plus 1 is not 6.
I thought you were adding the 2 there. Oh, 4.
4. How many ways can I get to this junction?
5. And then it's 6.
Okay, now here's where the numbers start to get much, much bigger. How many
3,
ways can I get to this junction?
3.
3. How about this one?
6.
How about this one?
10. 15. 21.
Notice how the numbers started to get big in a hurry.
Yeah.
How about this junction right here?
4.
4. Okay, how about this junction?
5.
How about this junction?
5. 6.
6. 1 plus 5 is 6. All right, how about this junction? Well, we're adding 1, or we're adding 5 plus the junction above it, 0.
5.
So that makes this
11.
5 plus 0.
5. 16.
Now, I can't do this one yet because I have this sum, but I don't have this junction right here. So let's keep going.
21 plus.
So what about this junction right here?
1. No, 21.
Well, we have
No.
this junction right here plus this junction here.
Which? Okay, yeah.
That's-
So it's something plus 0. Is it 15 plus 0?
Yeah. So it's 15. How many ways can I get to this junction?
21.
No, because it's the sum of the two preceding junctions.
36.
36. Because 15 plus 2 is 36. All right, how about this junction right here?
20.
20, because 5 plus 15 is 20. How about this junction?
56. Oh, things just get big in a hurry.
I know, it does get really big in a hurry. How about this one?
36. 92.
There you go.
That's nice.
So this way of calculating paths will work no matter what the maze looks like.
I was just missing a tens digit.
All right, now this problem is pretty cool.
I gave up on
And
that.
so I'll show you how I did it. And hopefully it's mathematically correct. I think it is, but if it isn't, go ahead and comment. All right, so we have the numbers 1, 2, 3, 4, 5, and 6. And they go for the variables Thelma. Oh, Thelma, using some repeated letters, is equal as a mathlete. Look at that, mathlete, yeah, see?
Oh, did
So,
you do that on purpose?
I'm pretty sure they did that on purpose.
Thelma math.
I know, the math counts test writers are kind of witty like that. So, what we're going to do is we are going to look for connections here and what we're asking. So we're asking, we have one whole number times one whole number times one whole number times another whole number and equals 1. Well, that means that m and a have to be either 1 or -1. Because if it's anything else, then we'll never end up with a product of 1, which means th has to be 1 or -1, l at e 1 or -1,
But it has to switch off each time, right?
well, we'll talk about that in a second. And TE also has to have a sum or a difference of 1, either positive or negative. Now, as you pointed out, a negative times a negative is a positive,
Oh, so it wouldn't matter.
but a negative, but a
Times a
negative
negative.
times a positive times a positive times a positive
It's a negative.
is a negative. So that means that we have to have either all positives
Or all negatives.
or 2 negatives and 2 positives, or
3 negatives and 1
4 negatives and no
positive.
positives.
1, 2, 3. Oh, yeah.
So those are the will work, and you'll notice that's half the different combinations of positives and negatives that we can have, because we have 4 things. Each thing has 2 possibilities, positive or negative, and so 2 to the. You're falling asleep on me. So that means there are like 8 different ways, I think, that we can make this happen.
Yeah.
2, 4, 6, 8. Yes. Okay. So
You can
just keep that in mind. All right. So now looking at this, I know that m and a have to be consecutive numbers because the difference has to be 1. So I know that m and a have to be consecutive numbers. Then I know th also have to be consecutive numbers, le have to be consecutive numbers, and te also consecutive numbers. Now ma is sort of in a class by itself, but th, well the t shares 2 different places, and the e's share 2 different things. So that means that if I have a t,
It's equal to the other t.
hold on a second. That means it has to be next to an E and an H.
Oh.
And the E has to be next to an L. So that's one way I can do it. Or, you know what I could do? I could go L-E-T-H, because the L and the E, the L and the E are next to each other. The T and the E are next to each other, and the H and the T are next to each other. Okay, this seems to make sense. So I can do either of those options.
Ow. My paper cut.
Your paper cut, of course. All right. So I'm feeling pretty good about what we're doing here.
Chickpea?
No, if I eat a chickpea, then I'm going to be crunching, and it's, we don't want to do. All right. So here we go. So that means the MA can either go in the beginning
Oh, that was a good one.
or it can go at the end. So that means we have MA followed by H. If you chew loud enough, everyone at home can hear too.
I know.
So I can have that combination. Or I can keep the MA and I can go,
Is my chewing distracting you?
yes, it's really distracting me. Because notice how I wrote a combination that didn't work as you're eating your chickpeas and crunching your chickpeas. Oh my goodness. Not helpful, Missy. So I can go H-T-E-L, or I could go L. You don't have to chew louder.
I know, I'm being quieter.
No, that's louder. You can just wait.
I'm hungry.
Or I can switch the A and the M.
I'm a
and
growing person.
And I can have two more, right? I can have H-T-E-L, A-M, L-E-T-H. But then, so this is 4 different possibilities. But I can also take these and put them over here. And that would give me 4 more legitimate possibilities. So that's a total of 8 possibilities.
It's always 8.
But wait, that's not the answer, because
It's in a fraction form.
no,
Probability.
it's probability. But hold on. Don't stop jumping ahead. We said that only half of the possibilities are going to work because we have to get the positives and negatives right. So that means instead of 8 total ways of doing this, there are only 4 that are going to work. So we know that 4 is going to be the numerator because that's the total number they're going to work. How many different possibilities are there? Okay. Well, how many different options do I have for t? Well, I have 6. If I have a number in for t, how many more options do I have for h? 5. How many options are left for e? 4, 3, 2, and 1. So the total number of options is going to be 6 factorial. 6 factorial is 720. Well, 4 goes into 720, so that is 1 over 180. And so that's how many different ways we can make this work.
That's definitely not